With this video, we're going to cover the entire lesson. This is kind of a shorter lesson, but I wanted to do a video and covering the entire lesson in case you wanted to be able to go back and review it or in case you missed the day or anything. But what we're dealing with here are what we call end behaviors of a polynomial. So this is kind of like, well, what does it look like at the very end of these? So with this video, I'm going to cover what the graph looks like, what the two ends look like, and we're also going to cover how to write limit notation is what we call that. Okay, so let's learn a little bit first here. If the degree is even, and the degree, remember, is your exponent, your largest exponent. So if this is like x squared, if this particular polynomial is an x squared or x to the fourth or x to the sixth, if that's your largest one, then your graph's going to look something like this. It'll look something different here in the middle, but essentially you're going to be going up in both directions here. And this is if assuming your leading coefficient, that's the number way out in front, is positive. If your leading coefficient is negative, then it's going to be going down in both directions here. It's going to have some other weird stuff here in the middle, but it's going to go down in both directions. Such as this one. If we look here, the leading coefficient is positive here, so it's going to look something like this. We're going to have a little bit different look right here. In fact, let's look at this one specifically. So we know the leading coefficient is positive. The graph on this one will look just like this. Okay, so it goes up in both directions here. So as x approaches infinity, then we need to think about what my y values are going to be. So as x gets larger here, as it approaches infinity, gets larger, what happens to my y values? Well, let's see. It's growing, and it's growing a lot. So my x values approach infinity as well. But we don't list it as x. We're listing it as f of x. Or not x, my y, excuse me. We don't list it as y, we list it as f of x. So my f of x approaches infinity. So as x gets larger, my f of x or my y gets larger as well. Now let's look if x gets smaller as it goes in the negative infinity direction. So in this direction to the left. As x gets smaller, as x approaches negative infinity, my f of x or my y value would still get larger, still approaches infinity, still gets larger each way. So we have, these are my two end behaviors here. F of x approaches infinity as x approaches infinity. That just means basically as x gets larger, my f of x, my y, gets larger as well. And as x gets smaller, my f of x or my y still gets larger, still grows. So let's look at kind of the opposite here. On this one, my leading coefficient is negative. So this is what my graph is going to look like. So as, let's deal with our x's first. As x approaches infinity, as x gets larger, my y values, or my f of x, will get smaller. So f of x approaches negative infinity. Now let's look at as x gets smaller, or as x approaches negative infinity. As x gets smaller, my f of x gets smaller as well. F of x approaches negative infinity. All right, so I want you to get a little practice on these. So I'm going to throw two of them up here. With these two, what I want you to do right now is push pause on the video. I want you to see if you can come up with this limit notation is what we call it. We're looking for the end behavior. As x approaches infinity, what happens to my f of x? As x approaches negative infinity, what happens to f of x? So push pause on the video now. I'd like you to try these two. After you've obtained your answers, come back and push play. Check your answers here. So as we look here, as x approaches infinity, as x gets larger, my f of x gets larger too. And as x gets smaller on this one, my f of x gets larger still. And that's controlled right here by this value out here, whether it gets bigger or smaller, whether it's a negative or positive. This one's a positive, so it means it's going to get bigger. Whereas this one over here is a negative, so that means this one's going to get smaller. All right. I want you to try these two as well. These are written in a different format. Same rules still apply, though. Push pause on the video now. I'd like you to work through both of these, obtain your limit notation. After you've completed that, come back and push play so you can check your answer. Check your answers here. Okay. And the same thing, this one is our negative out in front. That means as my g of x, as my x gets larger, as my x approaches infinity, then my g of x, my y values, get smaller. They approach negative infinity. All right, So now let's kind of look if the degree is odd. So this is x to the third, x to the seventh, x to the 21st. It doesn't matter just as long as it's odd. And it's a leading coefficient. I kind of got this little, and again, all of this middle part here changes depending on what the actual equation is, but that's unimportant. We're looking at the end behaviors here, the part that are in dark red. A solid red, I should say. All right, and now if the leading coefficient is negative, though, it kind of goes in the opposite direction here. Instead of going down, it goes up. So let's look at an example here. So this one is a negative out in front, so my leading coefficient is negative. So that means my graph is going to look something like this. So we're going to go through the same process here. As x gets larger, as x approaches infinity, my f of x looks like it gets smaller, approaches negative infinity. Now as x approaches negative infinity, as x gets smaller here, my f of x, my y value, gets larger. So f of x approaches infinity. All right, so now I want you to try these two. Push pause on the video now. Work out your solutions here, and whenever you're done, come back and push play. Check your answers here. And we'll go through, this is a little bit different one here. As x approaches infinity, as x gets larger, my g of x will also approach infinity. It'll get larger still. And as x gets smaller, my g of x would get smaller as well. All right. These are our last two. I want you to try these two. Push pause on the video now. Then I want you to obtain your answers. After you've obtained your answers, come back and push play. Check your answers here. All right, well, that'll conclude the video. If you have any other questions, I have a couple other shorter videos as well that you can go back and watch. Or you can go back in and watch this one again if it makes more sense.